A very good morning and welcome back to part 3 of the chapter Mensuration, the NCERT syllabus for class 8. Let's continue the exercises that we had stopped in the previous section. Moving on from exercise 11.2, question 4. Let's start off. The diagonal of a quadrilateral shaped field is 24 meters and the perpendiculars dropped on it from the remaining opposite vertices are 8 meters and 13 meters. Find the area of the field. Now this is very simple. As we know, the area of a general quadrilateral where a diagonal and two heights are given is equal to 1 by 2d into h1 plus h2. So now as we transpose this, we have 1 by 2d is at 24 meters here, so 1 by 2 into 24. h1, height 1, 13 and height 2, 8. So if we simplify this, 1 by 2 of 28 or 24 by 2 into 13 is 21, and now this 24 into by 2 is 12, and we have 21 here. If we multiply this, we then get 252 meters square, giving our final answer as the area of the field is equal to 252 meters square. Hope you guys got that question. Let's now move on to the next question. The diagonals of a rhombus are 7.5 and 12 centimeters. Find the area. Now, as we know, a rhombus is also a type of quadrilateral, except to calculate its area when two diagonals are given, it's a very easy formula. 1 by 2 d1 and d2. d1 is diagonal 1, here 7.5 and the other is 12. So now let's substitute them and find it out. 1 by 2 into d1 is 7.5 and d2 is 12. So now we've got that as well. And now if we just half this 1 by 2 and 12, we get 7.5 into 6, which is 45 centimeters square. Therefore, the area of this rhombus is going to be 45 centimeters square. Hope you guys got this question as well. Let's move on to the next one. Find the area of a rhombus whose side is 5 centimeters and whose altitude is 4.8 centimeters. One of the diagonals is 8. Find the length of the other diagonal. Alright. As you all know, a rhombus is a type of parallelogram as well. Let's take, this is a parallelogram and a rhombus is all with equal sides. Somewhat like this. Now, the area of this rhombus is 5 centimeters side and altitude, aka the height over here, is 4.8. Now, the only way of calculating a rhombus area when diagonals are given is the 1 by 2 d1 formula. However, if we consider this a parallelogram, this formula is also valid. So now we have the altitude and side. The area is to be found. So we just multiply both of them. 4.8 into 5 is nothing but 24 cm square. Now we've got the area of this rhombus. Using the same rhombus, whose area was 24, we have to find, if one of the diagonals is 8, we have to find the length of the other diagonal. Now, let's use the formula and transpose it. Now, 1 by 2 d1 into d2. Let's take d2 as 8, okay? Which is equal to 24. We already have the area. Now, we'll just 1 by 2 8 this thing. So, d1 into 8 by 2 is nothing but 4, which is equal to 24. Now, if we transpose this 4 here, d1 is equal to 24 by 4, which is equal to 6. Therefore, diagonal 1's length is going to be 6 centimeters. Hope you guys got that question. Let's now move on to the next one. The floor of a building consists of 3000 tiles which are rhombus shaped. Each of its diagonals are 45 and 30 centimeters in length. Find the total cost of polishing the floor if the cost per meter square is rupees 4. Okay, now there's a 3000 tile floor building. And the tiles are rhombus shaped and each tile's diagonals are 45 and 30. So to start this off, let's put out the number of tiles is 3000. I've got that, and let's calculate the area of one tile. So area of one of the tiles is going to be, since it's a rhombus, it's 1 by 2 d1 d2, and if we transpose this 1 by 2 into 45 into 30, move this on here, so that's 45 into 15, which is equal to 675 centimeter square. So now we've got that the area of one tile is going to be 675 meters, 60 centimeters square. Now the area covered by 3000 tiles. Area covered by 3000 tiles is nothing but 3000 into 675 itself. If we multiply it, we then get 2025, 675 into 3 and another 3 zeros. So this much 2025 and 30 centimeters square is going to be the area of 3000 tiles. And if we simplify it into meter squares, because the cost per meter square is 4 here and this is centimeters square. Now as we know, 1 meter square is equal to 10k centimeters square. So now if we divide it, we just add a point here, cut off these. So that's going to be 202.5 meters square. So now I've got the units in meters square as well. And to find the total cost, we just multiply the area of the tiles into cost per meter square. So the area of the tiles was 202.5 meter square into cost per meter is 4. So all in all, it gives us 810 rupees as our final answer. Therefore, the total cost of polishing the floors is going to be rupees 810. Hope you guys got that question. Let's now move on to the next one. Mohan wants to buy a trapezium shaped field. Its side along the river is parallel to and twice the side along the road. The area of this field is 10,500 meters square and the perpendicular distance between two parallel sides is 100 meters. Find the length of the side along the river. Alright, this is going to be very easy. Now, the side along the river is parallel and twice the side along the road. Now, we don't have these measurements. If the area and only the height is given, then we'll assume each side as x. So this is CD, and so let CD be x. Okay, so now if that side is x, since this is twice the side along the road, then AV is equal to 2 times of x or nothing but 2x. So now as we keep this, we can just transpose it into the formula. If the area of this field is 10,500 and perpendicular distance is 100, find the length of the side along the river. Okay, now let's put this into the formula. The formula for area of trapezium is 1 by 2 h into, okay, now that we've got the formula as well, let's transpose it. The height is going to be 100, and then parallel side 1 is x, parallel side 2 is 2x, the side along the river. So now 100 by 2 is 50, and x plus 2x is 3x. So 50 into 3x is equal to 10,500 meters square. And now if we multiply it, it's 150x is equal to 105 or 10,500. So x is equal to 1,500 by 150. Cancel off the zeros over here. And then if we divide it, we then get 70 meters. So now we have got that x is 70 meters. That means DC is going to be 70 meters. However, we're told to find the length of the side along the river. Now since this is twice it, we know the value was 2x. So if we put x here, 2 into 70, we therefore get this length of the side along the river as 140 meters. Hope you guys got that question. Let's now move on to the next one. Top surface of a raised platform is in the shape of a regular octagon as shown in the figure. Find the area of the octagonal surface. Now this is going to be very easy. As we know, regular figures, they all have equal sides. So all of these sides is going to be 5 meters as noted in the figure. Now find the area of the octagonal surface. If you notice something, we can divide the octagon into 3 similar shapes. Trapezoid 1, trapezoid 2 and a rectangle 3. So now if we just add the areas of all these shapes, we then get the total area of the octagonal surface. So now the octagonal surface area is going to be area of, let's put it as 1, area of 1 plus area of 2 plus area of 3. So now we'll clear it. And let's try calculating the area of the trapezium. Both of the trapeziums are equal, just to make sure that, because both of them are 11, and since it's regular, both 4 and 5 here. So now let's just calculate one of it. Let's take the first one, I, for example. Now we have type here 11 meters is its parallel length 2, height is 4, and since it's regular, 5 should also be the parallel height. So now using the formula 1 by 2, 4, 5 plus 11. Simplifying that, 4 by 2 is 2, 5 plus 11 is 16, and that gives us 32 meters square. So now we'll find the area of one trapezium, which means this area is the same for this as well. So now both the trapeziums, area of 1 plus area of 2 is 32 into 2, aka 64 meters square. Now we just have to calculate the area of the rectangle. That's going to be very easy. It's LB here, and using this figure we have 11 as the length and 5 as the breadth. So LB is equal to 11 into 5, which is equal to 55 meters square. Now what do? We have the areas of both of these figures and this one as well. So we just add them. The areas of both the figures was 64 meters square, and now 11 into 5 is 55 meters square. Add it. What is the answer you get? 119 meters square. Therefore, we come to consensus that the final area of the octagon is equal to 119 meters square. Hope you guys got this question. Let's now move on to the next one. There is a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita divided in two different ways. Find the area of this park using both ways. Okay, now we've got all the denotements and measurements over here. We also find both the sides are equal. So then we'll move on with this. Let's start off with Jyoti's diagram first. Jyoti's diagram, as we see here, is divided into two trapezoids, and through this figure we can analyze the middle is 30, 15, 15, 15, 15. Therefore, to find the area of Jyoti's diagram, we just divide this into two trapezoids, and both of them should be equal. So assuming the figure as such, 30 is parallel side 1. Height, if we look at it from this way, it's not going to be 15 because this total length is 15. This has to be divided in half. So that's going to be 7.5, and the top parallel side 1 is going to be 15. Please remember and check if it's half the length or the complete length. Okay, so now we've got that. Let's put it down. 1 by 2 h 7.5 into parallel length 1 30 plus parallel length 2 15. So that's going to be, or what if we do it another way? Since both of them are equal, over rather simplifying this and making it into a different decimal and multiplying it, what if we multiply the entire thing by 2? Don't you think that's easier? Exactly. So we just put the same formula, 2 into 1 by 2 is 7.5, and we'll just cancel those off because 2 by 1 into 1 by 2 is just 1. And 7.5 into 15 plus 30. So we can calculate the area of the entire figure. Now 7.5 into 45, and if we multiply through decimal multiplication, our final answer is 337.5 meters square. It's very simple, guys. I hope you understood. So we can come to the Jyoti's diagram is 337.5 meters square. Let's move on with Kavita's diagram. Firstly, we can see that Kavita's diagram, contrary to Jyoti's diagram, is divided as a triangle and a square, as shown in this figure. And now what we need to do is just calculate the area of the triangle and the square. So Kavita's total area is going to be area of triangle plus the area of the square. Let's find out the area of the square first. We can see that both the sides are given 15. So since the area is s square, transposing s for 15, we have 225 as the square's area. Let's put that in. Area of the square is 225. And now the area of the triangle as you can see, we have the base. Now it's 1 by 2 BH, right? The base over here is given just 15. However, we do not have the height. But something that we can see is the total height of this is 15. And if we transpose this 15 here, the remaining base is just 30 minus 15, which is equal to 15 and 15. So 1 by 2 B base over here is 15. And the other base, the height is 30 minus 15, aka 15. So that's 1 by 2, 225. And that gives us 112.5 as our final answer. Now we had 225, right? Plus 112.5. If we just add it, 733. So both Jyoti's diagram and Kavita's diagram is the same answer. Therefore, we find out that using both ways, both the methods are correct, and the total area of the park in both the figures is 337.5 meters square. Hope you guys got this question. Let's now move on. Diagram of the adjacent picture frame has outer dimensions 24 into 28 centimeters and inner dimensions 16 into 20 centimeters. Find the area of each section of the frame if the width of each section is the same. Now we have to calculate the area of each section of the frame, and each of the width is also same. Now we'll calculate height 1 and height 2 over here. They are unknown values because the width of each section is the same. So h1, we can see that there's an equal length over here as well, and this length is 20. So now both the height one is going to be 1 by 2, 28 minus 20, because we're not taking h1 only, we're taking this one also. So 1 by 2, 8 and 4. So height 1, aka this width, is going to be 4. Let's mark that off. And the same applies for h2 over here. There's a length of 16 and total length of 24. So h2 should be also 8 divided by 2, 4. So h1 and h2 are nothing but 4. So now let's calculate the area of each section. Area of trapezium A and C is the same. So let's start that off. Using this, A and C area is the same. So for both of them, the parallel length 1 is 16, parallel length 2 is 24, and height is 4. So using the formula 1 by 2 h, 1 plus 2. If we transpose it, we get 1 by 2 into 4, 16 plus 24. Now 4 by 2 is 2 and 16 plus 24 is 40. So the area of section A and C is going to be 80 centimeters square. Now we have to calculate the area of B and D because they both are the same as well. Now it's the same formula again. Height over here is 4, parallel length 2, 28, and parallel length 1, 20. So using the formula 1 by 2, let's just directly put it. Height is 4, 20 plus 28. So now if we simplify it, 2 into 48, which is 96 centimeters square. So then we then get the answer as 96 centimeters square for B and D. Therefore, the areas of A, B, C and D respectively is 80, 96, 80 and 96 centimeters square respectively. Hope you guys got that. And now the exercise 11.1 and exercise 11.2 is completely over. Let's now move on to the other topics that we're going to cover in this lesson. Now, you guys might be knowing about volume. Volume in short terms is space occupied by a three-dimensional object, aka a 3D object. It's a three-dimensional quantity. Now, volume is just the space occupied by any 3D object. That's a simple definition. That's all. The surface area is the measure of total area that the surface of an object occupies. Okay, in short terms, the surface area is the area which, if there's a 3D object, for example a sphere, Surface area is the area of the entire surface, the measure of it. Lateral surface area is the measure of total surface area excluding top and bottom. Surface area is the measure of total area across all its surfaces. Hope you guys please understand that. Lateral surface area is measure of the entire surface area excluding top and bottom. Okay, so volume, space occupied, surface area, entire surface, lateral surface area, entire surface except top and bottom. That's very clear. So let's find out formulas of volumes of different shapes. These are very common shapes. You guys know them very well. This is a cuboid. So there are three lengths over here. A length, height and a breadth. And using that, it's just very simple. The cuboid volume is LBH, or L into B into H. Length into breadth into height is going to be a cuboid's volume. Cube's volume, it's all the sides are equal for a cube. So if we just multiply it by 3 times, side into side into side, S cube. So S cube is the cube's volume. And now a cylinder volume, you have a height and a radius of the top and bottom circle. And using that, it's pi r square h as the cylinder's volume. Okay, L is the length, B is the breadth, H is the height, S is the side, R radius, pi 22/7 or 3.14. Very simple topics. Now, surface area of cuboids. Okay, let's decode this shortly. The formula for surface area of a cuboid is 2 into LH plus BH plus BL. In short terms, as you can see over here, LH is length into height, BH is breadth into height, and BL is length into breadth. Using the 3. Now this might sound like you have a formula over here, you get the formula. Again, over marking it up, we're going to understand how is it derived so we can get a more in-depth understanding. Okay. Now, as you know, surface area is basically sum of the areas of all the sides of a cuboid, right? Now, if we separate this cuboid into somewhat like this with 6 sides and different areas, we have to just add all of their areas. But there's a formula here, but we'll understand how is it, derived. Now we have 6 sides over here, calculating the area of all of them. Area 1 is H and L, got that. Area 2, LB, got that as well. Area 3, BH, BH, got that. Area 4, L and H, got that. Area 5, B and H, got that as well. And finally area 6, L and B. So all in all, we get this as H into L. We've got this part. Okay. Now, as you know, in algebraic expressions, you have to add like terms. Here HL, you have 2 like terms. Add them. 2HL. BL, you have 2 like terms. Add them. BH and BH, 2 like terms. Add them. Now the formula here is going to be 2HL plus 2BL plus 2BH. And since 2 is common in all of them, you know what we do, right? Factor out the 2 in all of them, and we have HL remaining plus BL plus BH. Therefore, we get the formula of total surface area of this cuboid as 2 into LH plus BH plus BL. Hope you guys got that of the formula and how is it derived. Okay. Now, lateral surface area. This is just very easy. It's just subtracting the top and the bottom. Now, we just have to have the total surface area minus top area plus bottom area. You can see here. How is it derived? Here. Total surface area, it's 2HL plus 2BL plus 2BH. And the top area plus bottom area, as you can see, this is B, BL, and another BL over here. So 2BL. Now, if from 2HL plus 2BL plus 2BH, if we subtract 2BL, strike it off, we have 2HL and 2BH. Now, as you know, we always have to factorize. So 2H and 2H is here. So take out the 2H, L plus B. So the lateral surface area is 2H into L plus B. To summarize what we did about cuboids, the total surface area is 2HL plus LB plus BH, and lateral surface area is 2H into L plus B. Hope you guys got that. Let's now move on. Surface area of cubes. Now again, the formula for the surface area of a cube is very simple. It's 6s squared. Now, as you guys know, cubes are made up of nothing other than squares. That's why all the sides are equal and all their sides also share the same area. So if we divide the cube again into 6 sides of faces like this, we just have to add all of the areas again. So area 1 is a square. Now over having to do it manually for the rectangle the cuboid as shown in the previous section, we can just come to a consensus that the areas of all the shapes divided here are the same because they're squares and all the squares have the same side. So if this is s square, then all of these areas must be s square. All in all, since we have 6 sides, we get 6s squares, and simplifying it, the total surface area is 6s square. That's very simple. Hope you guys got that. Let's move on to the next. Lateral surface area of cubes. Now again, no need of much explanation. This is total surface area minus top area and bottom area. Now top area and bottom area is just s square and s square because all the sides are same. So s square and s square is 2s square, and if we subtract it from 6s square, we get 4s square. This is by far the easiest surface area and lateral surface area you're learning in cubes. I guarantee it. Alright, so that's also very simple, and then let's move on to the next. Surface area of cylinders. Now this is quite a little tricky, to be frank. Okay, so the surface area formula of a cylinder is 2 pi r h plus 2 pi r square, aka 2 pi r into r plus h. Now it just sounds weird with all the symbols and stuff, so I'm just gonna go straight into it. Firstly, to derive how is the formula derived? Now over directly memorizing it, you may not probably understand how does this formula work. It's gonna go like 2 pi r h plus 2 pi r square. Over that, you can understand how it works, so you'll get more in clear understanding of the lateral surface area of cylinders. So how is the formula divided? Firstly, a cylinder can be divided into circles at the top and bottom, and the middle curved surface as a rectangle. We have the surface area of cylinders. Now we divide it into 2 circles, top and bottom, and the middle curved surface into a rectangle as shown here. Now, as we know, area of a circle is pi r square. So we take this one as pi r square and this one also as pi r square. So there we get 2 pi r square as the area of both the circles. Now we have to find the area of the rectangle. Now, as you know, the height is this distance. My bad, the other distance, sorry. This distance over here is going to be the height. Now when this curved surface opens, you can see that this becomes the height and this entire is a curved surface. So if we represent that as a circle, you know that the circumference of a circle is 2 pi r, right? Now if this is 2 pi r and this is height, then the total surface area of this surface is just going to be 2 pi r h. So now all in all, we have 2 pi r h and surface area is 2 pi r h plus 2 pi r square. Hope you guys got it. And lateral surface area is just 2 pi r h because you just remove these two and subtract it 2 pi r h. Hope you guys got it.